So, monocles are closer. Never mind. So, distance of the object is going to be at infinity, which is the incoming and the outgoing side of this lens. Now I want you to tell me the image distance in order that the image is at the eyeball's far point. Disagree with 17. 15. Since when I'm analyzing this lens, all distances are compared to the location of this lens, the eyeball's far point is 15 centimeters from the lens, even though it's 17 centimeters from the cornea. Everybody follow? So what I'm going to do is I'm going to give this person glasses where the image distance is going to be 15 centimeter. Now, the question is that positive or negative?
Negative.
Negative. Because?
The image is not on the outgoing side.
Yes, this image is not on the outgoing side. People wearing glasses do not like it. You know, there's this thing about personal space, right? Depending upon how comfortable you are. You know, some point you may say, hey, you're invading my personal space. Behind my glasses, most everyone considers that invading my personal space. So, we're not going to place this behind your glasses. So, there we are. What's that? Minus 15. Because 1 over infinity is 0, so 1 over f is 1 over minus 15, so f is minus 15. Okay? So you've just prescribed glasses for this person. Now, there's a problem with wearing these glasses, as nearsighted people know, and that is that they now can no longer focus on objects if you bring that object very close to their glasses. Okay? Because what happens is, once the image, because this person will now only look at images from this point on, once the image of something lands at 12 centimeters, this person can no longer focus on these images. So, sometimes it's referred to as the new near point. So, actually maybe I won't move that over. In this case, what I would like to do is I would like to find out where is an object with these glasses such that its image is at this person's near point. Okay? So I'm looking for an object distance with these glasses such that the image is at the person's near point. So, in that case, if the image is at the person's near point, what is distance image?
10.
10 centimeters. Positive or negative? Negative. 10 centimeters from the lens is 12 centimeters from the cornea. That is now an image at this person's near point. The focal length is going to be minus 15, and we'd like to know the object distance. How much? 30 centimeters. So, when this person puts on their glasses, they can see you guys fine. And in fact, they can focus on anything until it gets to be 30 centimeters from what? The lens, which is 32 centimeters from the eyeball. Okay? Beyond that point, when they try to bring the thing closer, it's fuzzy. So what do? If they're holding this thing
Take off the
Take the glasses off, and now they can focus on it anywhere from 12 to 17. Whereas here, they can focus on it anywhere from 30 to infinity, because the things at infinity wind up at 17 from their eyeball, and the things at 30 wind up at 12. Yes?
So if they wanted to look at something that's closer than 12, let's say a reading, they need a second pair of glasses.
Yes. So in that case, you may say, gee, 30 centimeter for your final object distance is awfully far, so maybe you ought to get progressive lenses in this case, because this person's lenses weren't adjustable enough. So all glasses that you wear all the time set objects at infinity at the furthest place you can focus on them. And then if the nearest place is not near enough, then you make objects that, then you make a more convergent lens down near the bottom, so that you can then bring things in. So I can focus this hand, when I look through here, I can't quite focus there. But I can bring it to here, if I look through the bottom part of my glass, because they're progressive.
I was wondering about it.
Yeah, it's kind of like bifocals, except it's better, because bifocals are A or B, invented by Benjamin Franklin. And then progressives make a smooth move from A to B. And the interesting thing is, your mind gets trained, so that when you try to look at something up close, I don't bring things here to look at them. I bring them here, and then I can look at it. So it just becomes a habit. But if you've never worn progressives and you put them on for the first time, you intellectualize things you do. I understood it intellectually, so I knew that I should be looking to the bottom if it's getting closer, things like that. But what you wind up doing is simply habit. You know roughly how far something is from you, and you just choose to look through the appropriate portion of the lens. Like right now, I'm not even quite looking at you through the middle of the lens. I'm looking at you a little bit through the bottom of the lens, just because I know, but I look at them through here. Yes?
Can you explain why we put diverging lenses on the nearsighted?
Okay. I drew it as diverging because I knew in advance it was going to be the answer. I didn't have to know that. This calculation gave me a minus. And then that was it. Yeah. Okay. If I put the image at the person's near point, that means the image is 12 centimeters from here. But lenses don't measure from your eyeball. Lens distances are measured from the lens. Since it's 2 centimeters from the eyeball to the lens, a thing that is 12 centimeters from the eyeball is only 10 centimeters from the lens. Now it's 10 centimeters on that side, so it is an image that is 10 centimeters away from the lens, but it isn't on the outgoing side. So that's why it becomes minus 10. Yeah? Sorry? Oh. 32 in principle is what someone would call the new near point. Because this object will be 30 centimeters from the lens, meaning it's 32 centimeters from the eye. So the new near point is 32 centimeters. So
would you take off points
from
for that?
12 to 32, the near point moves back by 20 centimeters. Yeah. Yeah, what happens is, infinity is a pretty definite thing. Everybody likes to see things in the distance. So what you do is you always place the image of something at infinity at the furthest point that somebody can see it. Okay? And then what happens is you let the lens do the rest of the adjustment. And that sets your near point. And when I first started teaching physics, ever since the first time I did physics, me and the whole class did the game of, okay, everybody pulling your finger to see it. And I could do this. I started teaching in 1990. And now, 21 years later, through an unfocused, it's beyond here, and that's why I had to go to progressive. So, you know, and I watched every year when I taught this class. Gee, I feel further from last year. And on and on and on and on and on until, you know, it got to the point where I wore 2 pairs of glasses for a while. Because I made the mistake of buying no line bifocals, which no one makes anymore. Because what no line bifocals were you could look at distance things to one spot, you could look at close things to another spot, and you couldn't see anything. Okay? And that was extremely disturbing to me. But then with more computer work, they're able to design a shape of the lens such that the lens gradually changes its focusing as a function of position across the lens, rather than one focus here, another focus there, and then just smooth in between. So, progressives are, never get bifocals, get progressives. And no line bifocals were for vanity. Yes, I was vain. And they were not for optics. And so, if you wear glasses 24 hours, your glasses are a tool. Don't go vanity. Go function. So when you need, when your near point moves away from your face as you get old, go progressive. Don't go bifocals. And yes, they're more expensive. And yes, if you get anti-reflective coatings, they're even more expensive. So, my typical glasses, fortunately I have a discount, but before I buy them with all the fancy stuff, they're usually about $600. Wow. So, yeah. Okay. A thin film of soap water appears green when lit from above. Calculate the thickness of the film if it appears green, and it appears green. Calculate if it appears green, and assume that this is the thinnest possible film that can produce green. Okay? If the film appears green, what does that mean? Does that mean that the green is undergoing constructive, or the green is undergoing destructive interference? Constructive or destructive? You see something reflecting off of it. Constructive. If this was destructive, you don't see. If you see green, it's constructive. Now, this is a thin film of soap water. So what that means is, you guys know blowing bubbles? Yep. You buy a little jar of the stuff, you pull the lid off, and you put the wand in, and it pulls up a thin film. So what I mean by that, for a thin film, I'm not resting this film on glass. Instead, I've got air, soap water, and air. And for all intents and purposes, the soap does not change the index of refraction of the water very much. So it's still n equals 1.33. Okay? So, in that case, each one of these reflections has a possibility of flipping, or not. And also there's a little bit of sliding due to the fact that one of these rays has a little bit larger distance to go than the other. What is the condition on reflection when you flip the phase?
That n is bigger in the medium.
Yes, the n is bigger in the medium that you're bouncing off of. And if the n is smaller in the medium you're bouncing off of, then you don't flip the phase. And you can think of this all the way to last semester when we had standing waves. Closed ends caused a reflection that had a flip, and open ends caused a reflection that had no flip.